Hello friends, I welcome you all to this session on graph theory. So today I will be telling you about plane graph or planar graphs. So what are planar graphs? Planar graphs are those graphs which can be drawn in a plane without any edge crossover. So consider this graph A, B, C and D. Now what type of graph is this? This is basically a K4, isn't it? Now if you look this graph closely, then at this point, there is a crossover of edges dB and AC. So now the question comes, am I in a position to remove this crossover? If I can remove this crossover, then then that particular graph will be what we call as a planar graph. So let us copy this graph. Let me draw it here. Now, what I have to do, I have to remove this crossover. Okay, this crossover I have to remove. How can I do this? Let us remove one edge from here. Let us remove this edge. Now, what is the edge which I have removed? The edge is basically BD. So what I can do is, I can draw this edge from outside such that the crossover gets removed. And now this particular graph, this full graph is in a plane, isn't it? And hence, this particular graph is what we call as a planar graph. So, if a graph can be drawn in a plane, then that is called as a planar graph. And the graph which has been converted from that where the intersection is happening to the graph where there is no intersection, that means it is now drawn in a plane, that graph is called as a plane graph. And they are very useful. Now, let us take some examples that whether we are in a situation to convert any graph into a plane graph or not. That means whether any graph is a planar graph or not. So let us take one example. Let's say I am having this graph. Now I want to see that whether there is any, let me copy this. So this is the graph. Now the question is the graph planar? Can I draw this graph without crossover of edges? So before that, you have to understand how many points are there where crossover is happening. Crossover is here, 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 at this point, at this point. So 1, 2, 3, 4, 5, 6 points are there where the crossover is happening. So can I draw this particular graph in such a way that no crossover happens? Yes, I can. There are several ways to draw it. One such way is, let's do what, let's take this as white. Let us remove this edge. Now what I'll do is I'll draw this edge from outside like this. Then what I can do, I can remove this edge also, and now I can draw this edge from outside like this. Again there is crossover here, here and here because of this particular edge. So what I'll do is I'll remove this edge and draw this edge from outside. Now if you look that in this graph there is no crossover of edges, and hence the graph, the original graph, what was my original graph? This graph is what we call as a planar graph, and once transformed, so this becomes the plane graph. You can also do the same thing here. Now there's another way, very elegant way. What you can do is you can bring this here. Now look, all the edges are independent. There is no intersection of edges, and hence the graph is a perfect example of plane graph. So this is a plane graph. Previously it was like this, but what you have done, you have bought this thing here or that thing on the right hand side, and there is no crossover of edges. Similarly, if this is my question, that is the graph a planar graph, is this graph a planar graph, then what I can do is I can start working on this. How I can remove the edges one by one and draw them in a separate way. So first what I'll do is I'll remove this edge, I'll remove this edge as well as this vertex from this place. Then what I'll do is I will bring that edge here and then draw it. Now if you look closely, no edge is intersecting, and hence this is a perfect example of a plane graph, and the original graph is nothing but a planar graph. Similarly, you can do here. So if you bring this here, it becomes a plane graph, or you can do it here, or you can bring these edges vertices outside. It is up to you. The only target is to manage the edges in such a way that no, or manage the vertices in such a way that no edge intersect, and if that happens, that becomes a plane graph. Now take this example. This is a very good example. How can I make this graph a plane graph, or is it possible to convert this into a plane graph so that we can call this graph as a planar graph? So I think there are ways. Let us see whether we are able to do it or not. If I bring this to here, and then what I can do is I can bring this 6 here or inside, and if I do it like this, again there is an intersection. Okay, so what I will be doing is, okay, let me bring everything onto this side, this this, and now write it properly. Now look, this is what, this is perfect example of a plane graph, no edge intersect. So the graph which I have shown you previously was an example of a planar graph. Now you are correct. Now take one more example, this one. So now the question is the graph a planar graph? So for that matter, what we have to do, we have to remove some edges so that the intersection can be removed. So let us do what? Let us remove this edge from here. Okay. Once we have removed this edge, then let us draw it from outside. Done. Very good. So far, so good. Now you do what? There is another intersection. This is the one. Let us remove this also. Okay. And then draw it from outside. Now once this has been done, there is no way you can remove this particular intersection. You cannot remove this crossover. Why I am saying that you cannot remove it? Let me show this to you. Let's say I remove this particular edge. Okay. So if I remove this edge, this one, so if I remove this edge, then what will happen? I have to draw it. I have to draw it from out. There is no other way. So if I draw it from out, look what I have to do. This is what I have to do. I have to cross this lane. And if I have to cross this lane, that means I'm not in a position to draw this graph on a plane. And hence, the original graph, what was the original graph? This one is not a planar graph. So what is this? This is 1, 2, 3, 4, 5. So this is nothing but K5. So K5 is non-planar graph. So friends, again I am telling you what is a planar graph. A planar graph is that graph where I am in a position to remove the crossover of edges so that I can draw the graph in a plane as a plane graph. Whereas if I am not in a position to draw that graph in a plane as plane graph, then that particular graph will be called as a non-planar graph. Okay, there are two ways to check planarity. One is Kuratowski's theorem. Another one is using your Euler's formula also, or Euler's method. So that we'll be taking in the next lecture or next coming lectures, wherever it is appropriate. So thank you very much for watching it and take care.